Good afternoon, everybody. My talk today is Stop Scheduling Like It's 1999. Green software needs better timing. We are going to look at how we as developers can have direct impact on reducing carbon emissions with just a few lines of code. And yes, it involves scheduling jobs smarter. My name is Ted, and for over 20 years I'm a Java developer working at First Aid Conclusion. There I'm on the team of the GreenScheduler, and that's our open source scheduling library. And I'm very proud to be presenting this for the very first time to other developers outside our company, here, DevOps.
Sorry for the interruption, but otherwise I get too much blobs. Yep.
All right. So I hope you like it, understand why we created this library, and I hope you will join us in our cause to build a greener environment. So this is the agenda. I'm going to do this in 3 parts. First, I will give you some background on electricity and carbon intensity. Then I will tell you what we built with it. And finally, how you can use it in your own projects. Let me first take you along for some background information. I will explain what carbon intensity is and why it matters for the environment. So in 2015, the United Nations introduced 17 Sustainable Development Goals, the SDGs. They are a shared blueprint for peace, prosperity, sustainability, ranging from zero hunger to clean water, education, and climate action. At my company, we align our work with 2 SDGs in particular. SDG 9 is about industry, innovation, and infrastructure, because we are software engineers. We innovate, we build digital structure. We want to make sure that we create a sustainable by design. And SDG 13 is about climate action. So the climate crisis is urgent, and every sector, including ours, IT, must contribute to emission reductions as much as possible. As developers, we like to think in features and performance, but there's the inconvenient truth. Every pod, every refresh, every job burns energy. At global scale, data centers already produce hundreds of millions of tons of carbon dioxide. That accounts for 0.5% of global emissions today. It's rising, especially since the rise of AI. And we often don't see it, but it's there, hidden in the corners of our data centers, running our code. So the impact of software industry is significant. So let me tell you some facts. 4 facts. Today, 1 to 3% of the world's greenhouse gases are emitted by us, IT. In Ireland, IT data centers use more electricity than all of its households combined. And it's estimated that electricity demand from data centers worldwide is set to more than double by 2030 to slightly more than the entire electricity consumption of Japan today. And last but not least, an observation in the modern world of AI, training GPT-3 likely, depending on a lot of factors, but emitted in the order of 500 metric tons of carbon dioxide, equivalent to driving a typical car, European or American, more than 100 times around the world. By focusing on these goals, we recognize our responsibility as developers to innovate responsibly and to take climate action through the software we deliver. So at our company, we saw a clear opportunity. Many of our clients run nightly jobs. Report generation, data crunching, you know the drill. And these jobs don't have to run exactly at 2 a.m. They just need to finish before the morning, before everybody starts, usually. And that flexibility is a chance to save carbon. So hands up, who here has a nightly job running right now? Yeah, that's quite a lot. Now keep your hand up if you chose the time based on the cleanliness of the electricity grid. Exactly. Yeah, most of us pick a time of 2 a.m., 3 a.m. because it's safe. Nobody's using the database, etc. But the grid is not equally clean at all hours. So let's talk about some green software principles first. Green software is carbon efficient software. According to the Green Software Foundation, there are only 3 approaches. Energy efficiency, use the least amount of energy possible. Hardware efficiency, use the least amount of carbon possible, or in other words, use less computers to do the same work. And carbon awareness, do more when the electricity is clean and less when it's dirty. And today we're focusing on carbon awareness because that's the lowest hanging fruit for many of us. Like I said, electricity is not equally clean. Here you see a few types of common energy sources, including well-known fossil fuels, such as coal, gas, oil, and renewables, such as solar, wind energy. And each of them has a specific impact on global warming. The measure for this impact is called carbon intensity. That's the grams of carbon dioxide per kilowatt-hour. So there's this little E in between. Most of us are not really accustomed to. It's the equivalent part. But what's it doing up there in the unit? Well, there are more greenhouse gases than just carbon dioxide. The carbon dioxide equivalent means we're not only counting CO2, we're converting all greenhouse gases like methane, nitrous oxide into the amount of CO2 that would cause the same effect to global warming. Here you can see that 1 kilogram of methane warms as much as around 27 to 30 kilograms of carbon dioxide. Yeah, that's a lot. But it can be even worse. 1 kilogram of nitrous oxide warms as much as 273 kilograms of carbon dioxide. So as an example, if a power plant emits 1 kilogram of methane and 100 kilograms of CO2, the total CO2 equivalent is those combined, 127 kilograms carbon dioxide equivalent. So I hear you think, why convert everything to CO2? There are more powerful molecules out there, better at trapping heat, like you see. It's because methane, for instance, is gone within 12 years from the atmosphere. But carbon dioxide is here for many lifetimes. It takes around 100 until thousands of years before it's completely absorbed by oceans, soil. So that's a real vendor lock-in, if you ask me. So this equivalent lets us express all emissions in a common comparable metric of global warming potential. And finally, if we want to compare the energy types I showed you before, we need to normalize them to the amount of energy produced in kilowatt-hour. And that's what the entirety is called carbon intensity. Now we can look at a comparison. Excuse me. And we see that the carbon intensity of electricity varies greatly depending on the fuel source. On the right, you see coal emitting more than 1,000 grams of carbon dioxide to generate a kilowatt-hour of energy. More than 800 grams for oil, 400 for natural gas, etc. And on the left, you see wind, solar, hydro energy emitting only a few grams. Now you know how we can use it to measure electricity generation. There are two things you should also know. Carbon intensity is a mix of many energy sources, and it changes throughout the day, the hour, basically the season. Carbon intensity varies by location, since some regions have an energy mix containing more clean energy than others. Here you see a world map with regions having a color between green and black. And that's the amount of carbon intensity. Take India, for example. They are heavily reliant on carbon-emitting fuel sources like coal and oil. Iceland, however, here has more renewable resources, such as water and geothermal energy. You can imagine Iceland. So their energy mix has a lower carbon intensity. Like I said, carbon intensity changes over time, per hour, per day, the season. And here you see an example of how the mix looks like on a particular time, a random day, random place. It contains coal, gas, and a quite significant part is made up of solar and wind energy. So what if 1 hour later the weather conditions have changed? We in the Netherlands know everything about changing weather conditions. For instance, the wind stops blowing, the windmill is going slower, and a cloud comes for the sun. So the amount of green energy decreased, but the demand stays the same. And you see that the remainder needs to be filled up by the good old fossil sources. And this increases the total amount of carbon intensity 1 hour later. So remember from earlier, if we can get the forecast of next day's carbon intensity, we could plan our job at the greenest moment, where the energy, the lowest, when the carbon intensity is the lowest. So how do we do that? That brings us to part 2, the green scheduler. So we built two things. One is the carbon intensity I/O API. It forecasts the carbon intensity per region. And we have the GreenScheduler. It's a library for either Spring Boot or Quarkus. It has a drop-in annotation. You just can replace your existing scheduled annotation for GreenScheduled. How creative. So swap one annotation and your job starts running at the greenest moment within your allowed time window, because that's, I will tell you about it in a moment, but you have to allow it a window instead of a fixed time. Our API connects with ENSO-A, the Association of Europe's Electricity Operators. It represents over 40 electricity transmission system operators, like TenneT in the Netherlands. And I guess it's a bunch of 34 countries across Europe. And it has information on all the available types of energy sources, such as consumption, transmission, energy congestion management. But we are mainly used in the generation of electricity, especially the day-ahead forecast and actual generation. Based on this data, we calculate the predicted and the actual carbon intensity. So this carbon intensity per fuel source chart I showed you before. That's the kind of mapping we have inside our API to go from the megawatts of NSOA to a carbon intensity value at several points at the day. So based on the carbon intensity and the job constraints, the scheduler finds the optimal moment to plan the job. Finally, some code. So on the left, you see the old way, the existing at scheduled annotation of Spring at 2 o'clock in the night. And on the right, the new way. That's the GreenScheduled annotation from our library. We keep the time zone, and we don't specify an exact time, but a window. For instance, between 2 and 7 a.m. The scheduler will now figure out the cleanest time based on the data from the API. It's that simple. It's same code, it's just smarter execution. I see a question. Yes, sir. Exactly. You're slightly ahead of me. There are some noteworthy attributes. So, yeah, the expected duration of the job, it's actually mandatory. It does not know by itself. It's a feature we have on the wish list of maybe doing a few runs, see the average of a few runs, and then basically remembering it. But as of this moment, you have to specify it yourself. So it doesn't actually change how long the job runs, but it tells the scheduler how much time to reserve to pick a start that will complete inside the window. And yeah, we have a carbon intensity zone for fetching carbon intensity data. Like you see in the example, NL for the Netherlands, and this maps to an area at NSOA. And yeah, the regular time zone, which was already there with Spring 2, with Spring also. It's hard to see any questions, so if there's anything, you just shout, okay? To make it visually, here's the graph of a random location on Earth with the amount of carbon intensity on the grid throughout the night. And this is the job with the regular fixed 2 a.m. Plan. The nightly job, it will always run at that same time. And you see here that between 2 and 3 a.m. The carbon intensity is pretty high compared to later in the night. So let's see time shifting in action. When we replace the logic with the green scheduler and a window between 2 and 7 a.m. And the job is now scheduled later in the night, and it starts at 4 a.m. because the data from the API says that's the hour where the electricity produced has the lowest carbon intensity. Well, like the gentleman said, if we would have indicated the job duration, for instance, is 2 hours instead of 1, the planner might have scheduled it somewhat earlier. Although it sees that at 3 a.m. the carbon intensity is higher than at 4, it's more beneficial to start it than compared to 4 to 5 to 6, for instance. It's all to optimize for the lowest total carbon intensity during the job's execution, but on the start of the hour. That's right now our granularity. Tricky word. Periodically, the green scheduler retrieves the day ahead predictions and the actuals. And based on the changing weather conditions and supply, then with the same job constraints, the scheduler might schedule every time a different starting point. That's not that difficult. We have created a calculator where we can compare a traditional run, let's say of exactly 2 p.m. at night, with the green scheduled alternative using the time window. And it gives us a bit of insight into the carbon savings. And it's depending on a lot of factors, But we see that by more relaxing your time constraints, the more the scheduler can optimize for the greenest moment. And more carbon savings are achieved. And I think that's awesome. Maybe if we could embed the original traditional time in our annotation, you would have run it the old way, and then we have the new way. Then, but right now we have this calculator of our own to do this, and we might see in the future how we integrate this into the stuff. So what else have we got? The regular Spring cron expressions could also specify to run on a specific day of the week and a day of the month. And here you see both examples running only on Mondays or running only on the first day of each month. And that's the fixed window scheduler. And next to this one, we have also a successive scheduler. It calculates the best execution time for tasks that need to be scheduled successively, considering a gap between executions and ensuring that tasks are scheduled at the optimal carbon intensity levels. So on the left, you see this regular Spring cron job, which executes every 3 hours. And on the right, you see this kind of equivalent, and that's the part that is if you're willing to offer exactness for freedom, and that's all depending on your use case. If you can do that, of course. If you're willing to offer exactness for freedom to choose the best moments, and this is a bit of a weird syntax. It says basically it's okay for the job to execute within maximum of 1 hour after the application starts up, and then every 3 to 8 hours. And the initial delay is just to give a bit more of control after redeployment, for instance. We could have said, no, minimum 3 hours, maximum 3 hours, like every 3 hours in the original way, but then there's not much opportunity to save carbon, is there? So here's what it looks like when the job is planned every 3 hours. It's on the wall clock, it's midnight, 3 a.m., 6 a.m., 9 a.m., etc. And in this example, our successive planner, however, will find the greenest moment within the initial 3 hours after deployment as a starting point, and then it will schedule consecutive runs within a gap of 3 to 8 hours. So let's say at some point it already planned this run at 3 a.m., just as on the previous slide. Then it will look 1 to 4 hours, 3 to 8 hours ahead, and it finds a moment at 9 a.m. which has the lowest carbon intensity. Again, it looks ahead, and hey, suddenly it becomes cloudy. Cloudy skies means less sun rays, but which will reach our solar panels. So the carbon intensity just went up. Because the scheduler updates every hour with new forecast data and it plans at the last responsible time, it won't plan at the original sensible 12 o'clock, but it will find a new better spot at 4 o'clock. Well, in the evening, the wind starts blowing, which is more green, but everybody finished dinner, starts Netflix, the sun goes down, etc., etc. So due to the ever-changing weather conditions, you have to keep the data you're basing your planning on up to date. And luckily, the library and the API will take care of that for you. So now you saw what it is and what it can do for you. What if you yourself want to get your hands dirty, I mean clean, and get started? So step 1 is to download either Spring or the Quarkus dependency. It's that simple. It's on Maven. We're not yet on version 1, so you know what that means. Step 2 is to go to carbonintensity.io. It's our website. It does not only contain the API endpoints for the library, but it also features a public information with some more stuff, a GitHub link, and an option to request this free API key. And the API key is necessary for the scheduler to get the actual and the forecast data from the API. So once you got it, you just fill it in your application properties or YAML file, and well, you're good to go. And step 3 is basically use the annotation however you like. It's that simple. It's a drop-in replacement, just a free API key, and to identify with the API and the annotation. Okay, let me show you our top 3 priorities we have on our roadmap. First of all, we're adding better dashboarding. It would be so much more fun to play with the predictions and the actuals and see all the possible savings up front visually. And yeah, we're reloading stuff, but that could be made more user-friendly with a nice UI or something else. Then currently only the Netherlands is supported, but we are working hard to connect more regions because it's all based where the data centers are, right? And thirdly, we're looking to expand in other Java scheduling solutions, areas, such as Apache Nivi, but we're also looking at other platforms, such as Python, Ruby, C#, .NET, or anything else. And we are definitely interested in all of the other use cases where scheduling can be made smarter, taken to a greener level. If you think you can help, please send me a ping or find me in these corridors this week. Now, what if you wanted to go into the code yourself? Of course, our GreenScheduler is on GitHub. The Spring and the Quarkus libraries and the GreenScheduler library, they're completely open source. And we'd love to get your feedback on things. Possibly contribute, but feedback, anything on the documentation, on how it works, or whatever you're missing feature-wise. We do have also a Spring Boot demo to showcase the integration with Spring Boot and scheduling, both for the fixed window part and for the successive part. And we believe that sustainability should be a core part of software development. And in the case of the GreenScheduler, by simply shifting job execution to times when energy is greener, we can significantly reduce the environmental footprint of what we create. I hope you want to join us in our journey with Team GreenScheduler, and we would really appreciate if you give it a go, because better timing is just one annotation away, you know. So I'm looking forward to answering any further questions you might have, or help you on your way. Else find me somewhere walking around on this conference, or reach out to me online. And I thank you very much for your attention. Thank you.
What happens when the API cannot be reached?
So the question is, what happens when the API cannot be reached? It will default back to the times you specified, and it will take the middle of it. So if you specified a window of 2 to 4 hours, it will take 3 hours. It will plan the job at the halfway of the window. That's basically currently our fallback strategy. Does that satisfy? Yeah. Okay. Yes, please.
If you have very much success, and then you run a very big consumer with it, wouldn't it make sense to plan different schedules to level out the consumption?
So basically the question is if we are very successful, and I hope we do, then would, for a very big company, and there's a lot of jobs going on, the question was, would it make sense to level out the schedules of the jobs? That they don't start at the same time. Well, it depends on the use case of your project, of course, if that's a challenge or a problem. If you have multiple jobs which could interfere, you might have to take care of that, of course. When you think of locking or jobs which actually wait before the completion of another job, that would be a good idea for the future. Yeah, yeah. Yes. Yeah, that's a good question. Do we have some net gains from well, the traditional run versus the green run? Because also, of course, this machinery takes additional computing power. Yeah, we do. It's hard to put a concrete number on it because it depends on so many factors. What would be the original run? What is the duration of the job? What would be the new timings? We see gains between 10%, 30%, 40%. It depends on the volatility of the day and the night, of course. You saw that graph. Basically, if the carbon intensity is a flat line throughout the time, then there's not much optimizing, and there's not much gains. I'm sorry for this consultancy answer, but it depends. Yes, behind the gentleman. Yeah. Okay, so I heard two questions. You are running on AWS and currently in Ireland. And when can you expect basically Ireland to be supported? We That's a good one. We haven't prioritized. We don't do it on alphabet. We might see where the most data centers are in use, but we're also having. Well, not every country is basically very. They don't provide correct values. Basically, it's all the way up to NSO-A, which just passes us sometimes empty data points. For Germany, we see that, and for Belgium. And I don't know where Ireland currently is in the list. We'll have to do. We can discuss about it. If you find Ireland is, yeah, it should be prioritized, then we'll work on Ireland first and see whatever is there in the data we get, which needs brushing up, because basically it's as good as the data we can get. Yeah, and the second question was. It's not in the top 3, but it's a very good suggestion for the immediate 4, 5, 6 items on the list, because we're very wanting it to not just be an isolated thing, but it has to. If we can integrate it in Kubernetes or OpenShift, that would be great. I'd love to talk to you about it more. Maybe we can help each other out. Yeah. Okay, great. Okay, yes, please.
Given that the new regions are coming pretty slow, what would you say is like the average good time for carbon intensity schedule? You know, is it like 3 or 4 in the night? Well, since we're not gonna switch to this scheduler for a long time, since we don't provide our regions, would you suggest what is like a good average time in the night to run the schedules? What's like on average the lowest carbon intensity periods?
Yeah, okay. So let me try to summarize the question. Since there's not since not all the zones are yet there, basically, and you wanted to start using it, what would be a good average right now if you would plan manually, for instance, your jobs at what point, would be appropriate? And basically, I think the answer is, you have to do the manual work right now. You have to find out where your data center is currently, in what region. You can go to ENSO-A and find out at that point the energy production, the generation of electricity right there. You'll have to find out how much is in the mix. So how much fossil fuels versus renewables. You have to have this mapping of coal, which has 1,000 grams of carbon intensity per kilowatt hour. So you have to calculate the carbon intensity yourself and then try to come up with some kind of figure number where in the night. But next night and next week it can differ. So that's basically this tedious work which we're supposed to basically automate away, so you don't have to do it manually anymore. Okay. I don't know how much time okay. So maybe one more question? Yes, please. The question is, have we seen this running anywhere in production? Are we monetizing it around that ballpark? No, we have. Well, we have only run it in internal projects, but we really love to see it out there, basically in the wild, because we're very interested in other use cases than we can come up with, and we're not planning to monetize it. So the logic, we like to contribute to the open source community. The GreenScheduled library is open source. The carbon intensity API not, but the library which actually does the planning with the carbon intensity data and finding optimal solution, that's open source. And we try to keep it that way. The API key is also free, and we try to keep it that way as long as possible. Right now, we're actually committed to making it a sustainable, better environment. And this is a side project of many enthusiastic developers. Some of them are here in the room, and we'd like to make an impact. Okay. Well, if there are any further questions, just come up to me, and I thank you for your attention again, and enjoy the rest of your week.